Okay, we're now on paper 2, where we're going to look at exercise 1. Now, since we're on paper 2, we need to remember that the GDC, or the calculator, if you prefer, but I typically say GDC because I find that a little bit faster, graphics display calculator is now available. That means that wherever possible, we should use the calculator. We should not be ignoring the calculator. We should be using it every step of the way that we can. Okay, with that in mind, let's read this question and consider, because of course the first thing to do is always to think about the question. So, Mia baked a very large apple pie that she cuts into slices to share with her friends. The smallest slice is cut first. Okay, we start from the smallest. The volume of each slice of pie forms a geometric sequence. Okay, so we already know that we're going to be using geometric sequences. We know that we start with the smallest and then it goes up from there. Okay, the second smallest slice has a volume of 30 cm3, or 30 cubic centimeters. The fifth smallest slice has a volume of 100 cubic centimeters. Okay, so let's think about what we've really just been told here. We have basically been told, okay, we've got a U2 that's equal to 30, and we have a U5 that's equal to 100. Okay, now, first off, it asks us, find the common ratio of the sequence. So, So, how are we going to find the common ratio of the sequence? Well, here's the thing. We have to think to ourselves, how do you get from U2 up to U5? What do you actually have to do? Well, the reality is that a geometric sequence is just, okay, you take your U and you times it with R. Every time you times it with R, you go up one step. So, for example, if this is UN, this will lead us to UN plus 1. That means that if we want to go from U2 to U5, well, U2 to U3 is U2 times R, right? So if we say U2 and we times it with R, we should get U3. It follows then that U2 times R, and then times R again. That would have to give us not U3, not U4, but U5, because you basically times with R an extra 2 times, so you move up 2 more. So instead of moving up to U3, you move up to 3, 4, and then finally 5. Okay, so with that in mind, that tells us, okay, so we actually just have to take U5, divide by U2, and we get R times R times R times R. So we have like 3 R's, but that's the same as U to the third, right? So, oh, look at that, we're almost done. Now what we need to do is we need to take the cubic root. I'm sorry I'm doing this a little bit ugly, but I try my best. U3 with U5 up here divided by U2. That should give us the result. I'm going to do this on the calculator to show you how it's done. Now, unfortunately, I can't seem to find a good way to record from the calculator, so I'm going to try my best to indicate it with a screenshot. Anyway, 15, 20... Right, of course. Okay, it wasn't. Yes. There we go. How disappointing. Okay, I keep. Sorry about that. I continually got it wrong when typing it in, but I will now show you the way that I did it. And I will take a picture of the calculator to show you what I mean. And I will put it over here. I'm going to have to scale this down slightly to make room for all of it, because we're going to need multiple pictures. So here we've got this right here. This is the system to use. You want it to look, let me circle it properly. You would like it to look like this, because of course, we're going to put in our U5, that was 100. And we're also going to put in our U2, that was 30. And then, of course, we're going to need our square root and, of course, our divide by. So, sorry, not our square root, our cubic root. I need to be careful. Cubic root. So, okay, that's how you do that. Now, the next point is how to write this answer. Now, there are many different ways you can go about it, but the way that I would do it is I would simply go and say, okay, what does it say here on the calculator? It says 1.493. If I were to take 3 significant figures of that, I have to take 1, that's the first significant figure, because of course it is, that's the first figure that appears. Then 4 appears, then 9 appears. That's 3. 3 significant figures, because the 3 after that is considered insignificant. It is too small to make a difference. We do not have to round up. The reason we don't have to round up is because, do you see what the next number is? This 3? This 3 is less than 5. The moment the next number is less than 5, you don't have to round up. So this should be 149. That's the answer for A. So A is now out of the way. I'm going to cross it off to show that it's out of the way. Now we have to find the volume of the smallest pie slice, or the smallest slice of pie. Okay, well, the smallest slice of pie, that must be U1. We've already established that. So we must be looking for U1. Think about what we showed up here. We showed that UN times with R gives us UN plus 1. Wouldn't that mean that if we took U, say, N plus 1, and we divided it with R, R, wouldn't we then get UN? Wouldn't we basically go down a step? As a matter of fact, we would. You can get U1 by saying U2 divided with R. So, all we need to do now is take our result from before, this one. We need to take 30, and we need to divide it with this number. I'm going to do that on the calculator now. Now, the way I'm going to do it is a little bit complicated. Let me try and show you it in detail. First, what I'm going to do is I'm going to have this selected. Do you see what I've done here? What I have done is I have taken 30 and then a little slash to show 30 divided by, then I've pressed up to select this. I select this because then when I press enter, it will input it exactly so that I get this. When I get, okay, that's a little bit ugly, but you get the idea. When I get this, this is the exact number. I'm not rounding at all. I keep it with as many digits as possible. The reason I do this is because I want a really exact answer. IB likes it the more exact your answer can be. So, what do you get as a result here? Well, when I do this on the calculator, I get the following answer. Let me show you. I get 20.08. So, what are we going to round this to? Well, here, the first significant figure is 2. Then there is a 0, and that is still a significant figure. Then after that, there's a dot, and then there is a 0. This is 3 significant figures. However, we have to keep in mind that since the next one is 8, larger than 5, we have to round up on this last figure. So it's actually 20.1. I've probably also accepted 20.0 because if you use an inexact number, you probably get 20. So that's okay. I accepted it in this case. But now for the last point, for the last question, because that was now B. We have found the smallest slice of pie as 20.1 cubic centimeters. I suppose in principle you really ought to write the unit afterwards. So you should say cm3. Okay, now the next one. Find the total number of slices Mia can cut from this pie. The apple pie has a volume of 55,760 cubic centimeters. Okay, how are we going to do this? Well, think about it this way. Total number of slices. That would be adding up the volume of each of these. It is, in effect, a geometric series kind of problem. So there we have to remember our geometric series formulas. I'm going to write it down because I seem to remember that it looks like this. Sn equals to u1 multiplied by, and then up here we would have 1 minus r to the n, and then below we have divide by 1 minus r. I seem to remember that this is the formula. If I'm wrong, well, I'm wrong, but I think that this is the right one to use. Of course, you being IB students, you should be looking it up in the formula booklet every time that you have the chance to make sure that you get it right, because it would be very irritating to get it wrong. But here's the thing. We know all these things, and we also know Sn. The only thing we don't know is exactly what n is. We know that the sum that we can look for, at most, is 5, 5, 7, 6, 0. That is the highest sum that we can possibly get. We also know that I can write 20 point, and again, I'm going to be quite exact here, and I'm going to go 8, 3 for U1, and then over here, we can do 1 minus, and I'm also going to be fairly exact here, 1.493, let's just do 4. And then to the n, divided by 1 minus 1.494. Okay. So we know that this right here, whatever n this would give us, if we could solve this for n, then whatever n we get, that must then be the number of slices that you can get. The number of slices. So, why not simply solve it? Because here's the thing. Remember, we have the GDC. We can simply go onto the calculator, and we can use, if you want, you can use nsolve, and I will do that first, because most of you seem to be familiar with nsolve. And type in this entire thing exactly as seen here. I'm going to take just a moment to do it, but with the moment I've done, I will show you what I have done, and then I will also explain how it works. Okay. How frustrating. I've made a typo, but it's fine. Here we go. So, this is what you can use to solve it. So you see here what I've done? What I said was I type in nsolve, and I can find this on the GDC if I want to. If I don't want to type it, I can go menu, and then I can go into algebra, and I can go numerical solve, and I will show you with a little screen cut now. So, like so. This is one way. You do not have to do this. You can also simply type nsolve. So just type nsolve on the keyboard. This is also possible, but then you have to start setting up this equation. You have to start setting it up, and you see that I've done that. I've got this part in here, and I've got this part in here, and then I've got this part in here, and finally I've got this part in here. I've been a little inexact here, but it shouldn't make a huge difference. In principle, you should be more exact, and you should keep as many digits as you can in the calculation, but for the result, you only need 3 significant figures. Okay, now then I write this little bit here, comma n. What this means is solve it for n. This basically tells the calculator what is a variable here. Solve for n. N is the variable. That is basically what this command is for, and it's very important that you include it, because otherwise you will get an error. If you don't include this, error. So you need this. Very important. I'm going to make a little note to show important. Okay, so once you have that in the way, you get a result. Let me see if I can take a picture of the result that I got, because I get this. And then that tells me, okay, we can cut 18 slices. And the reason I think we can cut 18 here is because if we think about it, what it's telling us is that, okay, 18 and a little bit, that's how many slices there are. But we don't count the last slice because that one would be too big. Like there's not enough pie left to make a real slice out of it anyway, not the kind that we want. So you can only get 8 slices maximum. Okay. Now, like I said, I wanted to show another way of doing this, so I'm going to try my best to do that. It's going to take a little bit of space, so I may need to expand my board a little bit, so to speak. Let's see if I can get a little bit more room. Okay, this is going to take a while. Let me just play around with it a little bit. There we go. Okay, so let me show you the other way to do it, because this is with NSolve. Now, personally, I don't like NSolve, and I've never liked NSolve, so I'm going to show you another way that uses the graphing system. So here, what you want to do is you want to go into graphing. In order to go into graphing, you simply have to press the home button, as in this one. Let me show you. You press this button on the calculator. Then, once you've pressed it, then you have to go down and you have to press graph. You can do this quite quickly, quite easily, but it's in here. It'll look like this on the calculator. Let me try and show you. Like so. You will pick this option here. Once you pick that, you will go to the graph system. Now, if your graph is blank, excellent. You can simply go for it. Then it'll look like this. However, your graph might not be blank, and that's okay. That's also okay. It doesn't really matter if it's blank or not, because if it's not blank, you can simply press Menu. Then you can go into Actions, and you can click Delete All. That will get rid of everything on the every bit of clutter, everything altogether. Of course, you must make sure that what you're doing is like you must make sure that you're ready to delete everything. Obviously, you don't want to delete something you want to keep. But this is a good way to get a clean slate. Once you've got that, you should probably also reset the window. You do this by going into Menu, then going into Windows/Zoom, and then picking Zoom Standard. If you do that, you will reset the view completely. I'll show you the command here, in case you didn't catch it. Let me get another picture. One moment. Yeah, this isn't the best method, but this is the best I could come up with because, unfortunately, Windows isn't the most cooperative. But here we go. So you can see that this, even though it shows here that's under Actions, it's not. It's under Window and Zoom. So let me use blue to indicate that the real one that you want here is this one. Yeah, okay. So with that in mind, then you've reset the window. You've completely reset the window. So let me take a moment here to scoot all of this up. Maybe not that part, but that's okay. Yes. There we go. So let's actually do this now. The way to do it is very simple. You want to set up 2 lines. You have to set up a line that is equal to the left side. So, for example, you would need this right here as one of your equations. This needs to be one of your functions. So you go into Scratchpad and you simply type that in. I'll show you what I mean. You want this to be one of your entries. Just a very, very simple function, literally just a number. That will be one of your functions. The other function that you'll want is one that looks like this. The only difference is that here we will actually have a variable. Now, we're going to use x instead of n, and the reason is because that's just the very way that it usually works for graphing. So I'm going to go ahead, and I'm just going to very, very quickly try and see if I can't do that. It should be possible. Here we go. So what you want is you want a new function that looks like this. Now, so then you will get them both in there, and I will try my best to draw them both. And initially, it will look somewhat disappointing because it'll look like this, you see. This doesn't really help us. It's not very communicative because you don't see the other graph. That means we're going to have to zoom a little bit out. So I'm going to play with the view setting. I'm going to go ahead and I'm going to pick a window setting that says that the X minimum goes from, say, 2. Now, let's say -1. And then I'm going to pick an X max of maybe 40. Y minimum should be from -1 up to, let's say, 100,000, because that should include the line that we want. So now what we get is this look. And now I hope that it's, okay, we need more space. But so now we've actually got something. We actually see here the shape that we're looking for. We're looking for, we want to see this intersection here. That's what we really wanted to see. And now we finally do. And because we see it, we can actually solve this. So let me show again how I got this kind of a graph. Or rather, let me show that in the first place. Windows zoom and then Windows settings. And then I put this into the Windows settings function. Looks like so. Because you can see here that I can choose Windows settings that make sense, because I won't be needing because obviously I will not need negative x's, so I keep it at -1. That's the lowest. At the highest I have 40, because I presume that I'm probably not going to be able to get more than 40 slices. This is just a guess. And then down here for the y minimum I say -1, because I know that I'm not going to get a y that's very low. I'm probably going to get one that's quite high. And then down here I see 1E15 or E5, which means this basically. And this is actually what I wrote on the calculator, and that's fine. The calculator will happily accept this, it will also accept this. Either way, it's fine. It depends on what you find most comfortable. Now that I've got this, though, where I can see very clearly that there's an intersection here, I'm going to highlight it in green. Once I see this, I just have to go onto the calculator, and I have to simply go ahead and press Menu. Then I press Analyze Graph, and I press Intersection. I will show you exactly the command I'm using by taking a picture of it. Here we go. This is the one that I'm going to use. When I do this, I just have to go ahead and select lower bound and an upper bound, and then I should be able to find the exact intersection I'm looking for. And it will come out to me like this. We're going to need even more space again. So there we go. Here we go. So this right here, this is the final result. And then I can actually see the number that I was expecting to get. And it will already have rounded it for me, which is quite interesting. So basically, this auto makes it 3SF, significant figures, 3 significant figures, 1, 8, and then 1. It automatically does this. You don't even have to think about it. Now, again, of course, sometimes you don't want 3 significant figures. Sometimes you want more. Then this might not be the best. This might not be the best method. However, it is possible to get more significant figures. It's just a little difficult, and I'll show you how to do it some other time. But that is essentially the alternative way to solve this problem, is to go there and then see this, and then you go, oh, okay, well, 18.1 again, 18 and a bit. The last little extra bit doesn't count because you can't really use that slice, so we ignore it and we say 18. And that's actually the answer, and that's the end of this question. I'm sorry that it took so long. Of course, realistically, a 6-mark question should not take you 24 minutes to solve. But because I have to show all of these different steps and all these different ways that you can use to calculate it, it takes a while. So understand that, like, the time I've spent here is not indicative of the time that it should take you, not by any stretch of the imagination. Thank you.